Alright, today we're going to go over a variety of trigonometry problems to help you master trigonometry. Because trigonometry often comes up in the form of word problems. But there are a couple of key types of word problems that show up again and again and again. That if you can master and get comfortable with, you can really master them. So I've had this come up in tutoring, and this is what I've suggested. Right? So let's start with a pretty common one, right? Where they'll give you a trigonometric function and ask you for another trigonometric function, right? Like let's say, okay, the cosine of angle x is 3/5 in a right triangle, right? And I want to find the tangent of angle y in the same function, in the same triangle, right? So I have two angles x and y in the same triangle, and I want to know both of their trigonometric values, right? So what can I do? Sometimes I'll give you the triangle, in which case you can do your standard, okay, I'll label the sides, and then I'll, use my, tangent is opposite over adjacent. But in many cases, they won't. They'll just give you this, and they'll say, what's the tangent of y? So what do? Well, one thing you can do is use your inverse functions, right? I can use my inverse functions to get my answer. So I can say, okay, I can take the cosine of -1 of 3/5 and get my x value, right? Because if I take the cosine of -1 of 3/5, I'm really taking the inverse cosine of the cosine of x, which really just cancels out the cosine of x and leaves me with just x, right? Why is that important? Well, it'll give me this value here. And since we're in a triangle, right, I know that x plus y plus my 90-degree angle has to equal 180 degrees, right? Because there are 180 degrees in a single triangle, right? So I'm really saying, okay, x plus y equals 90. Well, if I know x, right, I can just say y equals 90 minus cosine of -1 of 3/5. I can evaluate this out, find y by itself, and then plug that into the tangent of y with a calculator, and I can get the tangent of y. That's how you solve these problems. Almost always, you'll have these problems with a calculator. So you just need to know the thought process, and then you can use your calculator for finding the inverse cosine of 3/5, or finding the tangent of y after you've done that. Now let's go on to another more common problem that you usually won't have a calculator for. I say usually won't because, of course, you can make some problems require a calculator by just making the numbers really weird. But most time, these problems you'll have to do manually, right? So let's say I'm throwing baseballs at my garage door, and it's getting pretty damaged. So to preserve my door, I need a target that I can hit 5 feet above my head, right? So I'm here throwing baseballs, and let's say 5 feet above me, 5 feet above my head, some distance away, is a target. So just do an X here just to say, hey, here's a target. Right? I know I throw my baseball at a 30-degree angle above my head, right? So if this is my path from me to the baseball, right, there's a 30-degree angle here, right? I want to know how far I have to stand back to hit my target. So how far I have to stand back, that's saying, what's this distance here? I'll call this distance x, right? What's the distance from here to target, right? So essentially, I'm asked to find x. So what do? I can't use the Pythagorean theorem because, which is a squared plus b squared equals c squared, because we only have a squared. I mean, we need two side lengths to find x in this case, and we don't have two side lengths. But we do see that 30-degree angle right there, which suggests that we can use trigonometric functions to solve our problem. And indeed, we can. So I can say, okay, the tangent of this angle here is opposite over adjacent, right? So 5 over x. So I can say the tangent of 30 is 5 over x. But the tangent of 30 is also the same thing as the sine of 30 over the sine over the cosine of 30, not the sine of 30. Cosine of 30. Which is also equal to 5 over x. And these two functions both have distinct values, right? We can find out what those values are, right? The sine of 30 is always going to be 1/2. I'm actually going to get a different marker because mine's fading out. And the cosine of 30 is √3 over 2, right? And that's equal to 5 over x. So we can do some simplification. I can multiply both sides by 2 or √3 just to get them all on and cancel out this double fraction weird thing I got over here so that cancels out the 2's and leaves me with 1 over √3 is equal to 5 over x. Right? I multiply x by both sides. And actually, I'm going to erase this here to make more space. I get x over √3 is equal to 5. Multiply both sides by √3. So I can cancel out that. I just get x equals 5 √3. And that is my answer. And so I can say that's 5/3. And see, I use trigonometry there to help solve my problem, right? I find a trigonometric function, and I also find, and I set this equal to my knowns, my unknowns, but I also find the value of that function, right? So then I have two values I can work with in an equation, and I can solve them in that equation, which is probably just your standard linear equation, right? So that's how I solve those types of problems. All right. Let's do another type of problem, more, shall I say, tricky type of problem. But in order to do that, we're going to have to introduce 3 more functions. They're called reciprocal functions. So we know sine, cosine, and tangent. But today, I'm going to introduce cosecant, secant, and cotangent. Right? Now, cosecant is the same thing as 1 over the sine of x, right? So the cosecant of x is 1 over the sine of x. The secant of x is 1 over the cosine of x. And the cotangent is 1 over the tangent of x, right? If we were to rewrite this in triangle form, right? So we know the sine is opposite over hypotenuse, or so on and so forth. We would say the cosecant is the hypotenuse over the length of the side opposite the angle. The secant is hypotenuse over the length of the side adjacent to the angle x. And cotangent is adjacent over opposite. Now these don't come up too much, but they show up just enough that it's important to remember, and it's important to remember which one goes with which, right? So sine goes with the cosecant, cosine goes with secant, and tangent goes with the cotangent. Just remember that because they will show up in problems. Right? For example, right? Let's say I have, I'm given a triangle. Let's say it has side lengths of 5, 12, and 13. And I'm asked to find the cosecant of angle A, right? So I've said, hey, the cosecant of angle A, what's that? Well, the cosecant of any angle is the same thing as 1 over the sine of any angle. So what I'm really asking, what's 1 over the sine of angle A? So I have to find the sine of angle A. The sine is opposite over hypotenuse, right? The angle side opposite A is 12. So that's 1 over 12 over 13, or 13 over 12. So the cosecant of A is 13 over 12. And that's my answer. And that's usually where we'll use our reciprocal functions, right? Our cosecant, our secant, and our cotangent. They're not too important to use, but when they are, they will really be helpful to finding and solving problems. All right. Now, let's do some more. Right. So say I'm working as an electrician, and I'm attaching a guy wire 3 feet below the top of a telephone pole, and I've anchored the wire 14 feet from the telephone pole. The wire makes a 64-degree angle with the ground. How tall is the pole? So this looks like a pretty tricky problem. So I'm in the top part right here is 3 feet, so I'll mark it. And we have right now a triangle made out of the guy wire, right? So it's 14 feet on the ground away from the pole. That's one side. Then there's the length of the wire itself, which is the hypotenuse. And then we have this part of the pole. We don't know what this length is, and I need to find out in order to find out the total height of the pole. I call this length x, right? X is the side length on the triangle. And if you remember back to the earlier problem, we have like a similar situation where we'll say, okay, the tangent of 64 is equal to x over 14, right? Tangent is opposite over adjacent, and here it's the opposite side, and this is the adjacent side. The tangent of 64 also has its own value, right? It also has its own value. So we can say, okay, 14 times the tangent of 64 is x. I get it on my calculator. I find the tangent of 64. I get x, which is 28.7. I remember I'm with the total length of the pole, so I'm going to add 3 for a final answer, about 31.7 feet. That is my total answer. Looks like I can finally find the length of that pole, and hopefully get a promotion for doing so at my job. Look, I'm using trigonometry. So that covers a variety of the types of problems you'll see when using trigonometry, which are not always straightforward, right? They're not always just, oh, here's a triangle, solve it. But if you remember what to look for, right? Where to look for angles, where to look for side relationships that you can go off of, they're not too bad to solve. Just remember, when you're given a word problem, label your knowns, label your unknowns, label what you want to find, and things get a lot easier, right? So, for example, we saw, okay, well, the top of this pole is just 3 feet, right? So that's just going to be 3 feet. And the angle down here, angle to the ground, well, that's the angle between the hypotenuse here and the ground. It's going to be 64, right? So we start labeling our knowns and unknowns. And we also read carefully, right? This problem, right, we wanted the total height of the pole. So that means including this 3 foot tall top part, right? If we didn't notice that part, we could have gotten the wrong answer. So always when you're done, make sure you reread the problem to make sure you're giving what is asked of you. That's a very important part. All right, that's it. I hope you found this helpful, and I hope you have a great day.